Good morning, dear students. In today's class, we'll see the example based on sampling theory with the reference to the previous information, what we have studied in the previous lectures. So today we'll see a test of significance of sample mean. So here, to test whether the difference between sample mean x bar and population mean mu. So here you can consider the sample mean symbolically called as small x bar and population mean stand for mu is significant or not, means whether both x bar and sample mean what we have taken from the population is same with the population mean is both will same or no, we'll check it. So for that we need to consider the null hypothesis as there is no difference between sample mean and population mean. We'll consider this and whether this hypothesis supposed to be accepted or rejected based on what here values what we have taken for 5% and 1%. We have the values, so we need to check for that. So here we have the formula to solve those things. So here formula is for sample mean of is z is equal to x bar minus mu divided by standard deviation divided by root n, where this x bar is nothing but sample mean, this mu is nothing but population mean, this standard deviation is nothing but mean of standard deviation is mean of what here population, and sometimes here s will come. S stand for sample of means standard deviation of sample also. So here a small n belongs to what here number of samples. So with the help of this x bar, mu, standard deviation and n, will find the value of z, and this z value will compare with z alpha. Z alpha is nothing but our critical values, that is level of significance what we have seen in the previous lecture in the form of table. So what is level of significance for z alpha for 1% and 5%? We will check with two tail test, because we are will not specify for right tail or a left tail. So we'll see the situation how it works. So based on that we'll see whether it is two tail or one tail or right tail or left tail here. Okay, let's begin with the problems now. Now the question is, a normal population has mean of 6.8 and standard deviation of 1.5. A sample of 400 members give a mean 6.75. Is the difference significant? So solution, I have taken H0, that is null hypothesis, as there is no significant difference between x bar means sample mean and mu, that is population mean, means both are same I am considering here. So we'll see whether my statement is true or false, whether to accept this hypothesis or reject this hypothesis. We'll see now. So we'll collect the data. So given, so a normal population has mean so given a normal population has mean of, means population has mean means population mean means what here mu is equal to how much 6.8. then standard deviation, that is rho is equal to 1.5. a sample of 400 means n is equal to 400 members give a mean, that is x bar is equal to 6.75. so these are the data from the given question. So what I had considered here, there is no difference between this mu and this mu, this 6.8 and 6.75. we'll check whether it is true or no by using the formula. So we know that, or we have z is equal to, so formula is z is equal to, so sometimes negative will come, I will take modulus of that. So z is equal to modulus of x bar minus mu divided by standard deviation divided by root n. This is a formula. So simply apply the values. So here x bar value is 6.75 minus mu value is 6.8 divided by standard deviation value is 1.5 divided by root of n. N is 400. So simplify this with the calculator. So you will find, so on simplification, 6.75 minus 6.8 will get minus 0.05, and 1.5 divided by square root of 400, you will get what here, 0.075. So this division will get, so because of this negative sign, so this mod can be removed, absolute value we can consider. So 0.05 divided by 0.075, so we'll get the answer is 0.6667, that is mod z is equal to. So therefore mod z is equal to 0.6667. So now, so in the question there is no such instruction to test for 5% or 1%. So we'll test for both. So as we know that, so this value, so this value what here, I'll write like that. So it is, this 0.066 is less than 1.96. 1.96 belongs to what here, 5%, and also less than 2.58, which is nothing but 1%. So both, in both 5% also it is accepted because the less value. If the value, this value is coming greater than any of this, at that time what happened, it is rejected. So therefore, so less than 1.96, so we'll accept it. This the 0.667 is also less than what here, 2.58, that is for 1%. So what here, accepted. So therefore we have tried a conclusion. Therefore we need to say that H0 is accepted for 5% and 1% level of significance. Okay, so you can conclude it like that.